Welcome csc121, spring 2020, and this is the EX11 random number analyzer. And what you're asked to do in this exercise is to create an empty list, generate 10 random numbers that are going to get appended or added to that list. We're going to use the append method, which is a list method. And then we're also going to do a count method, which is going to count how many times a number showed up in that list. Here's actually an output example here. These are the random numbers 1 through 10 that were generated, and then this is the output that determined how many ones, how many twos, how many threes, how many fours, and so on up to 2. So we're going to do that a longer way first with a bunch of printouts, 10 printouts, and 10 variables to represent the count, and then we're going to use a loop to shorten that a little bit. But we'll do it the long way first. So I'm going to go back here, and we're going to start with import random. So there's already a nums list that started. It's empty, and we're going to append to it, and we're going to use a for loop to do that. So I'm going to say for I in range, and we're going to do it 10 times. So we're going to put 10 in the range for that, and we have to put our colon, and we're going to hit return so that it indents. And what we're going to do here is, first of all, generate a random number. So I'll just use rn equals, and I'll say random.randint, and it's going to be from 1 through 10. So we could use 1, 10, and it is inclusive in that list. And then also we're going to append to that list. So we're going to say nums, that's our list, dot append. And if you're not sure where to find this, under W3 Schools, if you go to Python lists and you scroll down to list methods, there's an append method. All the time with methods, it's typically the list, then dot, and then the actual function. It is a function, but it's a method because it's attached to a list, so it has to go with that. So there's a list dot, and then there's the method that goes with it, and then this one is appending whatever element it is to that. So they're adding orange to this list. Well, we're going to add a random number to our empty list. All that we have to do in here is just append the random number, and that's going to happen 10 times because we have it in a loop. Now, we're not going to see anything yet because we don't have anything printed out. So we could print out, and I'm going to make this go to the edge so that we could just print out one time. We're just going to print out our list after it's done. So we can just print out nums and just see what our list looks like once we're done. So we're going to do that first. So again, in this loop, it's going to generate a random number one time from 1 to 10. So each time it could do 5 threes and 5 8s if that came up randomly. And then that random number is going to add to a list, and so we'll have a list of 10 numbers. So let's see what happens the first time. And there it is. So there's a 3 and an 8, there's 2 7s, there's another 3, there's a 5, a 2, 6, and a 7. So 7s came up 3 times. And the idea of the analyzer is to analyze how many times that random number came up. So if there's like no 1s, and there's 1 2, but there's 3 7s, and there's 1 5, and there's no 4s, so that we can kind of analyze that a little bit. And maybe you could do that on a bigger scale at some point, but we're going to do this on a smaller scale, looking at random numbers from 1 through 10. Now, one way we could do that to analyze that is to use the count method. That's also a method that's in here with lists. And if you look at the count method, it typically uses a variable that's assigned to hold whatever count that is. So here we're saying fruits. There's a list here called fruits, and it says fruits count how many cherries are in the list. Now, this isn't a good example, but there's only 1, so it should return 1. So the value of x will be 1 after it runs this method. So we're going to have to do that for each number. We're not just going to count the cherry. If we had to count how many apple, how many banana, how many cherry, we'd do it 3 times. Well, we're going to do the same thing. So we're going to go here, and we're going to use a count method. So what we could do is just use a variable, and I'll just use it num to represent a number. And I'll say equals, and we're going to do the list, which is nums, because we're still looking at nums.count. And then we're going to count the number of 1s. And then we'll count the number of 2s, and then we'll count the number of 3s. And then we'll print it out. So I'm also going to put my print statement here. I'll say print, and I want to print both the nums. Like I'll do something like this. I'll do an F string. I'll do F and then double quotes, and inside there I'll put something like 1s, and then I'll put like a colon, I guess. And then in the curly brace, I'll put the variable of n. So whatever one comes up. So this is n right here. Now, actually, in this case, I'm going to use n1 for this because this is the first one, because then we're going to have n2 and n3 and so on. So we want to have one variable that represents each count, so we can't keep reusing it. So I'm going to do n1 first and just see what happens. Let's just try this. See how many 1s we have in our nums list. And there's 1, and it says 1s 1. So that works. So what you can do is repeat this 10 times, which isn't fun, but so that would entail doing something like this to get all those variable numbers. And then for printing, we're going to have to repeat this. So here's all our printouts, and here's our variables. With these 10 variables and these 10 print statements, it should show all the variables and all our numbers. So let's check it out. And there's our list, our nums list that got printed out. And here's our analyzer, which is showing 1, 1, 1, 2, 1, 4, 1, 5. There's 3 7s in the list, and there's no 0, there's no 8s, there's no 9s, and there's 2 10s. So it's analyzing correctly, except it took a lot of code to do that. And one thing after doing this, you might say, well, we did this 10 times, we did this 10 times. There's got to be a way to do this with a loop, because we did this 10 times with a loop. Well, there is. So we can do that with a loop. So let's try to loop this. Let's get rid of all these, because this is a lot of work and it doesn't look nice with all that code. And if you had to change something, you'd have to go through that again. So let's try to do this with a loop. Even before this, we're going to make a loop. And I'm going to say for I in range, we'll just do 10 again, because that's what we're doing up top. You could always do a length of the list if you wanted to, and make sure you get your I in there. Sometimes I forget to put the I in there. And what are we going to be doing now? We're going to be analyzing, and 10 times we're going to be basically counting. So let's put this in here. We can cut this and put this in here. I'll tab it over. Now, we're actually going to be using, this is counting the number, because remember when we counted, this was a 1, 2, 3, 4, 5, 6, 7. Now in this case, the loop, which basically runs through here 10 times, is going to be the number that's going to be getting incremented. And the nice thing about a loop, a for loop, is it increments on its own. It's going to go through 10 times anyway. So if we count I, which is going to be whatever number it's at, then we should get the count of that number. The first time through, it'll actually give 0, which we're going to fix. And then for here, we don't have to do n1. We could just do n, because we'll just keep repeating it. And then in the end here, we could just say print n. Now we have to be careful with this because we want it the same way. So this one is going to be n, which is the count. Because remember, this is the count. So we want the n there to be, this is going to be n, because the count is going to be over here. This is going to be the count. That's going to be n. N represents the count. This is going to be I. And you could go in here and put a curly brace. And you could even do it the same way. Instead of putting 1 in here, you could put I in here. And that way it'll print whatever number comes up. It'll say like 1s, and then this will be the count, and then 2s, and then the count, and so on. So this should work, except we might have an issue because a for loop will start with 0. And we want to start with 1. So let's see what happens. Okay, let's see. There's no 0s. There's no 1s. There's 2 2s. There's, let's see, we have 2 6s. So it's working, except it's going from 0 through 9. Now, we could change this by just going in here and saying 1 and 11. We're going to go 11 because actually the for loop, this will not be inclusive. It'll stop at 10. It won't return 11 with that. So we're going to put that at 11, and that should give us the 1 through 10 when we do that. Let's try it one more time. And there's 0 1s. There's 1 2. There's 2 3s. There's 1, and there's 1. There's 2 4s, there's 1, there's 1. So it's working. There's 1 10, there's 1 9. So it's working pretty well. It's just 3 lines of code here. So we didn't have to do those extra 10 lines of code, or actually 20 lines of code that it took to print them out. Now we could loop the print statement 10 times and loop the count statement 10 times just by using I, because I is the counter in a for loop. And we're just using that counter to output the number that it's at. Just by adding 1 to it, by starting at 1 and adding and going up to 11. And then n is what's being returned each time. So the count is being held as n each time. So each time it prints out the count. And then it resets every time it goes around, because then it counts the number of 2s, and then it'll return a different number. So that's kind of a shorter way to do that with just 5 lines of code, 9 lines of code. We had 20 lines of code just to print out everything last time. So that's one way that we're going to use loops, and we're going to use list methods to make things a little bit quicker, to analyze things. And as we get more familiar with lists, there's a lot of things we could do with them. So they've helped us with random numbers. They've helped us with the lottery and other exercises. So here it helped us analyze numbers basically by counting the frequency of the number showing up in a random number list.